In this video, we're going to prove the alternating series test. If you have a series of positive terms, but the sign alternates, a1 is positive minus a2, which is positive, plus a3, which is positive, minus a4, which is a positive term. This converges if all of the three conditions are met. The terms are all positive. At some point, an is always bigger than the next term. That is, the terms are getting smaller, and a sub n must approach 0. Assuming that those three conditions are met, the series will converge. Now, the proof is in two parts, where the first n terms are even or odd. If n is even, then let's just define n a little bit better. N is equal to 2m, then the sum of the first n terms equals, we'll call it s sub 2m, the sum of the first n terms. This is equal to a1 minus a2 plus a3 minus a4. Now notice that the even terms have a minus in front of it. So plus all the way up to plus the term before, the last one, a sub 2n minus 1 plus a sub 2n. Now, if we were to bracket it like this, notice that the left bracket is at an odd value and that the right bracket is at an even subscript. That is, those last two get bracketed, especially since there's m of them. Now, each of these terms are going to be positive. Or 0. Okay, so basically s sub 2n is a sum of positive terms, is a sum of positive terms. So s sub 2m plus 1 is going to be bigger than s sub 2m. Hence, s sub 2n is increasing. Now, let us look at this. S sub 2m we know is a1 minus, well, I'm supposed to take away 2m, sorry, a2, but I'm supposed to add back a3. If I have a minus in front, I basically take away a3. And then I'm supposed to take away a4, which I'm doing, but add back a5, which is what I'm doing. whoops, if I write negative a5, because the negative distributes and you get plus a5. And this goes all the way down to, if I'm in a space, now notice what's in the bracket. The first term in the bracket is an even term. So we're going to have a2m minus 2 minus that, minus the next term a2m minus 1, and then minus a2m. Minus a2. Now, these are all negative. Actually, I take that back. These are all positive. These are all positive. These are all positive. So this quantity is less than a1. So S2M is bounded above by a1. Any increasing sequence bounded above has a limit. That is, the limit as n goes to infinity of S sub 2m is equal to L. Suppose n is odd. Say n is 2m minus 1. No, I rather say plus. Now, Sn plus 1 is Sn. Sorry, S2m plus 1 is S2m plus that last term, plus a sub n plus 1. But the limit as n goes to infinity of the a sub n's is 0. That's one of our conditions, that the an's go to 0. So the limit, I guess this should have been a 2m plus 1. So the limit as m goes to infinity, I need to check something. This should have been m right here, as m goes to infinity. So the limit as m goes to infinity of s2m plus 1 is equal to the limit as n goes to infinity of this. It equals s2m plus 1. s2m plus a2m plus 1. But limits distribute over a sum. So we have the limit as m approaches infinity of s2 sub n plus the limit as n approaches infinity of a2m plus 1. The first limit is L from earlier, plus that limit is 0, so we get L. combining these two results, we have that the limit as n goes to infinity of s sub n, whether n is even or odd, is equal to L. And that's exactly what we wanted to show. We wanted to show that it converges. And remember, S sub n is a1 minus a2 plus a3 minus a4. And if we push n to infinity, then it's actually all of them. It's actually the summation. It then goes from 1 to infinity of -1 to the n plus 1 a sub n. This is going to equal L. And that's all we wanted to show, and we did. Be careful. You need to show this for both cases, n is even, n is odd. Let me know how you like this proof. I like reading your comments. And please, subscribe and leave some feedback or some comments about what videos you would like for me to make up. Okay, thank you. Watch and learn.